This is activity 2, matching equation moves from lesson 3, balanced moves. And as long as each move is balanced, as long as it matches, then that move is allowed. And so this is an activity that solidifies that idea. And so you have 6 different moves for the first step in balancing equations. And you're given 5 different first moves. So this is the equation, this is the first move, the equation, first move, equation, first move, and you're supposed to match them. And one is left blank, you're supposed to fill that one in on your own, make up an equation that uses that first move. So I'm just going to write the move at the top here and find the equation that matches that. And so you multiply each side by a -1/3. So when you multiply, you have to think about, or you should think about, the multiplicative inverse. What's the multiplicative inverse of a -1/3? Well, it is -3. So you want to look in the equation for -3 somewhere. And that's when you're multiplying using the multiplicative inverse, usually you're removing the coefficient, the number that's right next to the variable. So let's see where that happens. So I'm going to look for a -3 that's right next to a variable. This doesn't always work. Let's see if it works in this case. So here's a -3 that's next to what's inside the parentheses, and a -1/3 of a -15 is in fact 5. So this is probably the correct match. And you might check each one of these. Does this work? A -1/3 times 3 is going to give you a -1 instead of a +1. It doesn't work on this one. This is a +1/3. Doesn't seem to work on any of these other ones, but it does work on 5. So a -1/3 times a -3 gets rid of this -3 as the coefficient of this term. And so you're left with 4x minus 3, and a -1/3 of -15 is +5. So the next one. So when you add something, you're getting rid of that whole term usually. So what's the additive inverse of a -3x? It is a +3x. So I'm going to look for a +3x down here somewhere, and on each side, see if I end up with the next step. So the very first one here, 3x plus a -3x, that gets me to 7, and a -3x plus 5x gets me to 2x. So it looks like the answer is number 1. And so you might check through these other ones to see if they work in any way. Here's a -3x plus 12x is going to get you back to 9x, not 4x. So this one doesn't quite work, and the answer is number 1 here. So the first step in solving this equation, or balancing these moves, is to add a -3x, and that gets you to 7 equals 2x. And the idea is that you have to do that to both sides of the equation. You have to keep both sides balanced by matching that move on each side. Okay, the next one, add 3x to each side. So in this case, you're going to look for a -3x. The additive inverse of a +3x is -3x, and you would be removing that -3x. And do I have a -3x anywhere where that might work? And it doesn't look like I do. And in fact, this is the one that's left open. None of these work. So add +3x. That's not going to work. That's not going to work here. This is going to be 6x. This is going to be 15x. It's not going to work for any of these. And so I'm going to go down here, and I'm going to just write adding +3x on both sides of the equation, and then come up with something. You can come up with anything. Now, if I'm adding the additive inverse, then I want to use the additive inverse here, which is a -3x. I'm going to add a +3x to get rid of that. And here you can put anything, any number of x's, and a number on this side. And then you can add a number here, whatever you want to do. And so your first move is adding a +3x to get rid of this -3x here. And so you're left with 5x plus -8 equals 5. The next one, so this one works. The next one, add -3 to each side. So usually when you're adding, you're getting rid of the number in this case because there's no variable there. So you're going to look for a +3. So you add a -3, that removes that +3, you end up with 0. So add a +3 here, that's not going to work. Add a +3 here, that's not going to work. Add a +3 here. Actually, this looks like it might work. I'm sorry, I'm adding a -3. I'm saying the wrong thing. So I'm looking for a +3. I'm adding a -3 to that. So add a -3 here. Still doesn't work. Add a -3. It gets rid of this 3. But that's not what this step says. Add a -3 here. 10 plus -3 is 7. This remains the same, not doing anything to this. And 4 plus -3 is 1. And this remains the same. So it looks like number 3 is the answer. So if you check the rest of them, you're going to see that they don't really work in any way. It's a little bit tough. If I add a -3 to this side, this is going to be -18. So they don't work at all. So I'm going to add a -3 here. Usually you wouldn't do this. Usually you'd get rid of the entire value by adding, in this case, I'd add a -4, not -3, and make this 0. But it's okay. What they're showing you is any move you make, as long as it's balanced on both sides, you can make that move. It's okay. So it might be easier for you to make a partial move. Take away some of this, makes it easier for you to look at, whatever you want to do. All right. Multiply each side by 1/3. So when you're multiplying, you're usually getting rid of the coefficient. So what's the multiplicative inverse of 1/3? It is 3. So here's 3 as the coefficient of x. 1/3 of 3x is x. So this one is not going to work. 1/3 of 12x is 4x. 1/3 of 3 is 1. And 1/3 of 6 is 2. So it looks like this one works. So you have to multiply each term by 1/3. And again, this is not, you would usually multiply this by 1/12 to get rid of the coefficient and to make this 1x, but it's okay. As long as you make that balance move on both sides, you can make this a simpler equation to look at. So the answer is 2. 1/3 of 10, that doesn't work. 1/3 of, this is a -1/3 here, so that doesn't work. And 1/3 of a -3, that doesn't work. 1/3 of -3 is going to give you a -4x minus 3. And 1/3 of -15 is going to give you a -5. So that one doesn't work. So the one that is correct is number 2. Take 1/3 of each of these terms, you get this next step. 4x plus 1 equals 2. The next one, multiply each side by -3. So now you're going to get rid of usually the coefficient, which in this case is going to be the multiplicative inverse of -3, which is a -1/3. So do I have a -1/3 anywhere? And I do. It's right here. This is a -1/3. So times a -3, it's going to make this 5x. And 12 times a -3 is in fact equal to -36. So this one works. A little bit hard to look at, but it does work. -3, this becomes 5x, and a -3 times 12 is -36. And that's it.